Welcome to this explainer on ordinal utility analysis. Today, we're decoding the hidden math behind how we make our everyday choices. Have you ever wondered why you buy, say, 3 bananas and a loaf of bread instead of 4 apples and a carton of milk? Well, as it turns out, there's a fascinating, highly structured logic behind every single purchase you make.
Our roadmap for this explainer is pretty straightforward. First, we'll look at the limits of measuring utility. Then we'll get ordinal utility theory explained. After that, we're mapping preferences with indifference curves, breaking down the rate of substitution, getting a reality check with budget lines, and finally, achieving consumer equilibrium.
Okay, let's jump right into Section 1, the limits of measuring utility.
So historically, economists used what we call the cardinal approach. This old-school theory tried to measure human satisfaction in absolute objective units called utils. It also assumed the marginal utility of money stayed completely constant. But come on, is that really realistic? As your income goes up, the value of a single dollar absolutely changes for you. Enter the ordinal approach. Ordinal utility argues that we humans simply rank what we prefer. You don't need to know exactly how many utils a cup of coffee gives you compared to a cup of tea. You just need to know, hey, I prefer coffee first, tea second, and water third. It's an entirely relative ranking system.
Moving right along to Section 2, Ordinal Utility Theory Explained.
Now, to play this particular economic game, we have to establish a few basic ground rules, or assumptions. First up, we assume you, the consumer, act rationally to maximize your own satisfaction. Second, your utility is strictly ordinal, meaning you just rank bundles of goods. Third, there's a diminishing marginal rate of substitution. Basically, the more you have of something, the less you value getting one more of it. Fourth, your total utility is based on your entire basket of goods, the whole shebang. And finally, your preferences have to be mathematically consistent. Economists call this transitivity. If you like basket X more than Y and Y more than Z, well, you absolutely must prefer X to Z. Makes sense, right?
Which brings us perfectly to Section 3, Mapping Preferences, Indifference Curves.
So imagine you're looking at different combinations of oranges and bananas. Every single combination that gives you the exact same level of satisfaction connects to form this downward sloping shape. Whether you have 1 orange and 10 bananas, or you swing all the way over to 7 oranges and just 1 banana, your total satisfaction remains exactly the same. You are literally utterly indifferent between these baskets. And that inward bow shape it has, that convexity is a direct reflection of that diminishing marginal rate of substitution we just talked about.
But here's a fun theoretical question. What happens if you have a whole map of these preference curves, where higher curves mean more overall satisfaction, and 2 of them accidentally intersect? Can they ever actually cross paths?
The short answer, no way. Because of our rule of transitivity, intersecting curves are mathematically impossible for a rational consumer. Think about it. If curve 1 says you're indifferent between bundle A and bundle C, and curve 2 says you're indifferent between A and B, then logically you have to be indifferent between B and C. But wait a second, bundle B clearly contains way more goods than bundle C. A rational consumer is always going to prefer having more stuff. So this intersection creates a massive logical contradiction. Bottom line, indifference curves can never, ever cross.
All right, let's look a little closer at that math in Section 4, the rate of substitution.
That brings us to the marginal rate of substitution, or MRS for short. The crucial takeaway here is that MRS is simply the number of items of one good, say bananas, that you are perfectly willing to give up in exchange for just 1 extra unit of another good, like oranges. And you do this while keeping your overall happiness perfectly constant. Because you're continuously sacrificing one thing to get another, the mathematical slope is technically negative, but we usually just focus on its absolute value to keep things simple. Here's how it plays out in reality. As you hoard more and more of one good, you become increasingly less willing to sacrifice your other goods to get even more of it. At first, you might be totally fine giving up a lot of bananas for an orange, giving you an MRS of, say, 2.0. But as you keep swapping, you start feeling a little starved for bananas, right? So your MRS drops to 1.6. Keep going, and you'll only give up 0.8 units. The rate steadily, inevitably diminishes. This is the exact mathematical reason why that indifference curve bends the way it does.
Infinite desire is great, but it's time for Section 5, Reality Check, Budget Lines.
Because here's the harsh truth. You have a fixed income. That means everything you buy has to fit on or perfectly inside your budget line. The math is pretty straightforward. You take the price of your first good, multiply it by the quantity you buy, and add that to the price of the second good, multiplied by its quantity. That total absolutely must equal your total income.
Anything beyond that boundary line is a luxury you simply cannot afford right now.
Of course, reality changes over time, and so does your budget. If you get a raise and your overall income increases, your entire budget line shifts outward. In parallel, you can suddenly afford higher levels of consumption across the board. Take a pay cut, it shifts right back inward. But what if just one price changes? Let's say apples go on sale, but your income and the price of bananas stay exactly the same. In that case, the budget line actually pivots. The anchor point on bananas stays put, but the line swings outward along the apple axis, making the slope flatter. So remember, price changes alter the slope, while income changes alter the whole position.
Now for the grand finale, Section 6, Achieving Consumer Equilibrium.
A rational consumer is always trying to reach the highest possible indifference curve while staying firmly within their budget line. It's kind of like overlaying a map of your wildest desires right on top of the strict, rigid line of your bank account. You want to push out as far as you can. The absolute sweet spot, what economists call the consumer equilibrium, is found at the exact point of tangency where that straight budget line perfectly kisses the highest attainable indifference curve. Any curve higher than that is unaffordable, and any point lower on the budget line means you're just not maximizing your potential happiness.
If you want to look at it mathematically, this perfect equilibrium happens exactly when the slope of your desires equals the slope of the market constraints. That means your marginal rate of substitution, the rate you are personally willing to trade goods internally, is perfectly exactly equal to the ratio of their actual market prices. When those two rates align perfectly, you have optimized your basket. You literally cannot do any better given what's currently in your wallet.
Now, while this elegant model perfectly proves how rational consumers reach equilibrium, it does leave us with one really fascinating question. Do you actually calculate these slopes, tangency points, and diminishing rates when you hit the supermarket aisle? Or is all this complex calculus just running silently in the background of human intuition? It's definitely something to ponder the next time you're agonizing over apples and bananas. Thanks so much for joining me on this explainer.